We're now ready to move on to our required pre-paving information. And to do that, of course, we'll like to turn on our concentrator box down here and power up our ToughPad. And that's going to allow us to open up our software and start to input the correct data. We're now going to open up our RDM software. This will either automatically open, or you can do what I just did on the desktop, and we will open up our project settings by pressing Collect. Now, once we're navigated to our project, we're going to create a new project, and this is again the project info portion of our software. So we'll press New Project and press Cancel when it says Transfer Current Project Information to New Project. This is because this is the first time we'll be setting up this project. Once you've collected data for a day on your given project, you can select Transfer Data to New Project because likely you'll want the same settings from the previous day. So now we're going to press New Group. And this group should be associated with the entire construction project, where all the data you're collecting associated with that project is going to be associated with your project group name. For Minnesota DOT, that is our SP number, or our state project number, which we'll input now. SP 7606-96. That's where, and we'll press Accept. That's the project group name that all of our data will be saved under. Now we're going to move on to New Project Name. This will be our route number, which lift we're testing, as well as the date of paving that we're doing the testing on. So for this example, we're going to be testing on Trunk Highway 61, and then we'll do an underscore, followed by our lift number, and this will be our first lift for this project, so we'll go L1 underscore, and now we're going to put our date of paving. So we'll do today's date as our day of paving. So 2020 4-digit year dash month dash date. So our project name is TH61 underscore L1 underscore 2020 05 19. We'll be using 3 sensors. So we'll select 3 there. And this project is located in Wabasha County. And we put the county here for location because that helps us keep track with our GPS what county coordinates to use. Our lateral offset reference, this is where we're setting our reference line. And for us, we use our center line as our reference. And this comes in handy when we're keeping track of what location we are in terms of offset away from our center line. The next step is to select left side, and this is something that is currently not used and being changed for RDM 2.0. With RDM 2.0, just as a side note, everything is from the perspective of looking up station, which makes this lateral offset reference side invalid. So for now, we're just going to select left side for consistency's sake. Equipment operator, we like to put our 3 initials, Kyle, Edward, Hoig. So I put KEH, and the comments is a good place to put anything special about the project you're on. For this one, we'd just like to say that it's a Superpave 5 mix. So we're going to make note of that here. And with that, you can save your project and move on to the next step. This brings us to our sensor configuration page. Oftentimes, this will already be preset to the configuration that you had it set automatically, but you want to ensure that your leftmost sensor is in fact the ID that you have on that sensor. So in our case, we're in good shape. We don't have to go to this drop-down menu to change anything because our left sensor is in fact sensor 113, middle sensor is 114, and right sensor is 115. These checkbox locations are where you indicate the master sensor, and as we mentioned when we were connecting our DMI, our center sensor 114 is our master sensor where our check mark should be located. The last thing we'll want to input as part of this sensor configuration page is the location of our different sensors relative to the center sensor. So our center sensor, you can see here, is by default 0. Our left sensor, we already know that it's to the left of the center, so we're just going to put a number here that's associated with the distance. So this is 2 feet to the left of our center sensor, so we're going to put X line position 2. For our right sensor, we're going to also put 2, and that again is the magnitude in feet to the right of our center sensor. So we're now ready to move on to the next step because all of our inputs are correct. We'll press save and we'll move on. We're now ready to connect our GPS equipment. This is an optional procedure here if you want to have a high accuracy GPS. And the 3 components we'll want to get our high accuracy GPS include our receiver. We have a Trimble R8 receiver. We have our MiFi, which allows us to connect to our virtual reference station. At Minnesota DOT, we connect to the MinCores network. And then we also have our controller, which receives the internet and the receiver fix and allows for it to correct, and so we're spitting out our corrected high accuracy GPS when it's connected to our GPR system. So we're going to turn on all 3 of our components here. So the first thing we'll do is we'll turn on our MiFi, and it'll just pop up on the screen there when you know it's on. And then we're also going to turn on our R8 just by holding the green button here, and you see the lights will initially illuminate and then they'll start to do their startup procedure. And then the last thing we'll do is turn on our Trimble TSC 7. And you see the Trimble logo coming on. That means that we have all 3 of our components now powered up, and we'll take you through the process. You're actually done with your MiFi and your R8 at this point, and now everything is controlled here from your controller, and we'll make sure that these 2 components are working properly to get our corrected GPS string coming out of the R8. The first thing you'd like to do when you have your 3 components for the GPS connection powered up is check to make sure you're getting your wireless connection. This is the name of our MiFi, and it says connected and open, which is a good sign. That means we're ready to connect to the VRS network. So now we're going to want to open our Trimble Access program. You can do that by double clicking, and you see that Trimble Access logo pop up. That means everything is loading. And the next thing you'll want to do is open your project, and each state probably has a different way that they connect their GPS equipment to their VRS network. For us, we connect through our MinCore system. So for us, what we do is we go into our preloaded program project, and we set up a Maplewood test project here, and we're going to double click there. And that opens up our settings here, and you can see it can see 11 satellites right now, and it also shows you how much battery you have both on your controller and on your external GPS R8. And now it looks like we're connected to the satellites, so we can start to spit out that information we need. And for us, we do that by going into Measure and Measure Points. And at this point, it's establishing a connection with its virtual reference station and the R8 receiver. It's 90% complete, and when it's fully complete, you actually see this nice green check mark that lets you know your initialization has been gained, and we're effectively spitting out our NEMA string to get our corrected GPS. Now that we have our 3 GPS equipment powered on and we've set up our controller to send out the NMEA string, we want to go into our PaveScan software and make sure that we're actually seeing the coordinates as they're coming in. To do this, we're going to press Project Info. We're going to press Properties, and we're going to press GPS Settings. Once we're in this location, you're going to want to make sure that your GPS time continues to count up. That's an indication that you're actually reading your GPS coordinates properly. For us, on this specific system, the COM port, which is an indication of where our GPS is coming in, is number 7. The current software does not automatically detect which COM port it's coming in, so you sometimes have to cycle through these ports to find the correct one. For example, if we were on COM port 4 and pressed Test Settings, it says it's connected, but you don't see the time counting up. This is an indication that you are not seeing the NMEA string. So you'd want to continue to cycle through until you see the correct COM port, press Test Setting, and as soon as you see the UTC counting up, you know you have the correct NEMA string coming in. You can also check your GPS latitude and longitude fix because typically there's a little bit of variation in those numbers at the very small decimal places. Another thing I would like to point out is the baud rate. We preset our GPS settings to have a baud rate of 9600. You can also set a baud rate at these various other values. For example, we've used 115-200. It doesn't matter which one you choose, it just matters that whatever one you set your GPS receiver to, you need to select that when you're in this location. Another 2 values I'd like to point out are the inline offset and the crossline offset. The inline offset indicates how many feet away our GPS receiver is from our center sensor. So in this case, our center sensor is 2.67 feet forward from our receiver. So in this case, with the convention that GSSI set up, that would be the negative direction. So we input a negative 2.67 feet in the inline offset. The other offset you need to tell the software is how far in the cross-line direction your receiver is in relation to your center sensor or master sensor. In our case, it's half of a foot offset to the left our sensor is, so we put negative 0.5 feet into the cross-line offset. Once you've done this and input these values, you're ready to go. So if you were to be inputting your cross-line offset, you would have input that there, pressed enter, and now pressing test setting, or well, you can press test setting just to make sure everything's working properly, and then you can go back. And at this point, you know you have a correct GPS and MEA string coming in. We're now in the project properties page, and the only thing I'd like to point out on this page are the two things that we always make sure are checked. That includes use stationing format. That indicates that we're going to be using the surveying language when we're out there with this device, which is in feet, but with a plus before your final two digits. And we also like to make sure auto start distance is selected. This ensures that once you finish a pass, it will automatically start you at the stationing where you ended. And of course, you can override that if you're not starting in the spot where you stopped. But these are the two things I wanted to make sure that you have selected, and the rest is just set to the default values. So once you have these settings the way you like them, you can press save.